Hi children, welcome to another chemistry class. In this class, we are discussing the chapter polymers. See, from the chapter, stereotype questions usually what we find in the exam papers, but nowadays we are finding a lot of questions based on the structural entity of various polymers, monomers, and the type of bonding related. So let's have a look at the typical questions from the chapter. Right? Can we start? Ready? The first question. Caprolactam used for the manufacturing of. All of you know caprolactam. Caprolactam is finally giving you nylon 6. All of you know that. Nylon 6 is obtained from caprolactam. Nylon 6 is obtained from caprolactam. And what is the reaction? This is what the reaction. This is caprolactam, which upon hydrolysis you get aminocaproic acid. It's breaking over this region as it is indicated. You get aminocaproic acid, and aminocaproic acid upon polymerization, you are getting nylon 6. Nylon 6. Okay. Various other polymers, all are known to you. Terylene, so-called dacron, nylon 6,6, Teflon, which will come in our discussion, the subsequent questions definitely. Okay. So the answer for that is third choice. Next question. Nylon 6,6 polymer. We want a nylon 6,6 polymer. You know nylon 6,6 is obtained by adipic acid and hexamethylene diamine. Hexamethylene diamine and adipic acid is giving nylon 6,6. Nylon 6,6. And the 6,6 stands for that number of carbon atom. This is adipic acid with the hexamethylene diamine. This is adipic acid. There are 6 carbon atom. Adipic acid contains 6 carbon atom. This is wrong given. It is CH2 4 times. CH2 4 times and CC 6 carbon atom. And there is CH2 6 times. Hexamethylene diamine and adipic acid. And the obtained polymer will have such a structure. And it is the second choice correct answer. It's a polyamide. 6,6 stands for what? All of you know. 6 carbon atom in adipic acid and 6 carbon atom in hexamethylene diamine. Okay. Next. Regarding cross-linked or network polymers, which of the following statement is incorrect? That is what the question. Examples are bakelite, melamine. That is correct. They are formed from trifunctional monomers. That is partially correct. It can be monofunctional, bifunctional, trifunctional. That is partially correct. They contain strong covalent bond in their polymer chain. That is also correct. They contain covalent bond between various linear polymer chain. That is not correct. The correct answer must be 4. At the same time, I find that second choice is also partially incorrect. So let us examine. The answer is B and D. Exactly. So the answer key will go for 2 and 4. In cross-linked polymers, monomer units cross-link to form 3-dimensional network. Examples, melamine, bakelite, etc. They are thermosetting polymers. On heating, they undergo permanent heating. Bakelite is a condensation polymer of phenol and formaldehyde. Melamine, see all these are there in the NCERT. Cross-linked or network polymers contain covalent bond between polymer chains. These polymer chains may or may not be linear. See what is the problem here is that is also partially incorrect. They not necessarily be linear. They not necessarily be linear. It can be branched, cross-linked. That is the point. Now, network polymer contains, okay, fine. Cross-linked polymers can be formed from mono, bi, or tri. That is what the point. That is what the point. It can be monofunctional group, bifunctional group, trifunctional group. So we should go for, see, even though partially incorrect, there are two statements, option 2 and option 4. Option 2, it can be mono, bi, tri, etc. Option 4, not necessarily always it is a linear chain. Hope you understand. Next one. The biodegradable polymer is the very famous nylon 2, nylon 6. You might have seen in the NCRT, the portion is completing with the discussion of that particular polymer. Nylon 2, nylon 6 is a biodegradable polymer. And this is what the nylon 2, nylon 6 obtained by glycine and aminocaproic acid. Glycine condensed with the aminocaproic acid, and you are getting nylon 2, nylon 6. Note down this structure, and NCRT itself is asking for you to draw that structure. Hope you've seen in the textbook. It is obtained by glycine and aminocaproic acid. Just a comment is made, and then they ask you, can you draw the structure? This is the structure of nylon 2, nylon 6. Once again, nylon 2 means 2 carbon atom, 6 means there are 6 carbon atom in aminocaproic acid. Okay, next question. A linear chain polymer is HDP, high density polythene, where the chains will be linear and close packed, therefore density is maximum. While if there is branching, it stands for LDP, low density polyethylene. Okay, so the answer is second choice. This is what the linear polymer, you can see, polythene linear polymer, which will go for HDP. HDP will be linear, LDP will be branched in character, while bakelite melmac, they are cross-linked polymers. Okay, next. Branched chain polymer is LDP. Option C, LDP is a branched chain polymer. LDP is a branched chain polymer. You see, this is LDP and that is HDP. HDP is linear molecular chain and they are closely packed. While LDP, there is a limitation for close packing as it is having a branching in it. Clear? Next one. A thermoplastic is, all are thermoplastics, sterylene, PVC, polythene, all are thermoplastics, while bakelite, melmac, etc. will be thermosetting plastic. What is thermoplastic? Which can be heated and remolded into a different shape. While thermoplastic, setting plastic, you can't do it. If you try to heat it, it will make a fusible mass. Okay, next one. And this is what terylene, so-called dacron. If referred in the NCRT, obtained by ethylene glycol with terephthalic acid. And it is basically a polyester. Next question. Monomers of the following polymer. This is Novolac, a linear polymer formed by phenol formaldehyde resin. It is phenol formaldehyde resin. Methanol means formaldehyde. Phenol formaldehyde resin. That is the linear polymer obtained, so-called Novolac, where the cross-linked polymer is so-called bakelite, one of the oldest plastic discovered by Bakeland. Right. So it is phenol formaldehyde resin, so-called bakelite. Next. Chloroprene has the structure. Chloroprene. This is chloroprene. 2-chloro-buta-1,3-diene. Chloroprene. The polymer of which is neoprene, artificial rubber. That is chloroprene. And this is what chloroprene, 2-chloro-1,3-butadiene, which polymerizes, you are getting neoprene, synthetic rubber, right? Next one. The one which is not a condensation polymer, Nylon 66 is condensation polymer, and the answer is PTFE, polytetrafluoroethene, is a chain polymer, is a addition polymer, chain growth polymer. And the answer is option B. Option B. It is PTFE, polytetrafluoroethene. This is tetrafluoroethene, which upon polymerizing you are getting PTFE, the so-called Teflon. Teflon, used in non-stick cookwares and various laboratory systems and all. They are highly resistant to reaction to corrosive chemicals. All of you know it is Teflon polymer. While this is glyptal. Glyptal is obtained by ethylene glycol with phthalic acid. Glyptal is obtained by ethylene glycol with phthalic acid. While dacron means already commented, ethylene glycol with terephthalic acid, you get dacron. Clear? Next one. Natural rubber is cis polyisoprene. Cis polyisoprene. Natural rubber, to be precisely called latex. The so-called commercial rubber is cis polyisoprene. Another variety of natural rubber is trans, but that is not a commercial rubber. That is trans polyisoprene. I think all of you know. Gutta perca. Gutta perca. That is trans polyisoprene. Natural rubber, so-called latex. That is cis polyisoprene. Of course, trans is also natural, but that is not a commercial rubber. So the most suitable answer is option B only. Okay. Next one. This is what cis polyisoprene, and this is what trans polyisoprene. Have a look at this. This is cis and this is trans. You see that? Cis and trans polyisoprene, and this is so-called gutta perca, and this is latex. Next one. The correct representation of terylene dacron, already we have seen it is a polyester. You look at this region and get your answer. It is polyester. Terylene obtained by ethylene glycol with a terephthalic acid. Right? So it is option A. Polyester, already commented. Ethylene glycol with the terephthalic acid, you are getting terylene or so-called dacron. Next one. The correct representation of nylon 66. Nylon 66, already we have commented. Nylon 66, this is the answer. It is obtained by hexamethylene diamine and adipic acid. Hexamethylene diamine and adipic acid, which contain 4 plus 2, 6 carbon atom here and 6 carbon atom here, and it is 66. Artificially, globally famous nylon fibers, known after the two important cities in the world, New York and London, where it is first manufactured. Next. And that is nylon 66, hexamethylene diamine with the adipic acid. Option A is correct answer. Polymer which is used for making ropes and carpet fibers. Polymers which are used for making ropes and carpet fibers is polypropylene. Option B. Polypropylene is the correct answer. Option B, polypropylene. They are used for the range of plastic packaging, plastic parts for machinery, equipments, and even fibers and textiles. This is obtained from propylene. This is propylene, and this is polypropylene. Polypropylene, very famous plastic. Next one. A copolymer of styrene and 1,3-butadiene. Styrene 1,3-butadiene is BUNA-S. Styrene 1,3-butadiene. BUNA-S. Bu means 1,3-butadiene. S means styrene. Na means the catalytic agent sodium. That is how BUNA-S comes. BUNA-S, BUNA-N. We are learning in the textbook. It is option D. BUNA-S. And this is BUNA-S, 1,3-butadiene with styrene. And this is the polymer BUNA-S. You have to have a look at the meticulous look at the structural entity of the polymers, because that is how the questions are mostly coming nowadays. And what is this? This is butyl rubber. This is butyl rubber, option A, which is obtained by isobutylene and isoprene. Isoprene with isobutylene, you are getting butyl rubber. Next one. Correct statement about LDP. LDP. Option A, correct one. Option B, correct one. It is all the above. All are the correct statements regarding LDP. They are all statements. You have to go through that statement. Strictly picked from the textbook. That's all. Okay. Next one. Viscose. Viscose. Viscose is the product obtained by, see, rayon fibers. Rayon fibers, very famous in the textile industry, obtained from cellulose with alkali and CS2. Refer NCERT, semi-synthetic polymers. There is a classification, natural polymer, semi-synthetic polymer, synthetic polymer. So this one explained in the semi-synthetic polymer, viscose rayon. Viscose rayon. And you can find the applications which are commented here. Dissolved in viscose. Viscose is semi-synthetic material used in clothes, upholstery and bedding materials. Next one. Aminocaproic acid on polymerization gives. Aminocaproic acid on polymerization gives nylon 6. Aminocaproic acid on polymerization gives nylon 6. Already commented. Already commented. See, caprolactam. Upon hydrolysis, you get aminocaproic acid. Aminocaproic acid upon polymerization, you are getting nylon 6. Already commented. Already commented. Next. Chemical name of melamine. Chemical name of melamine. Melamine polymer. Melamine polymer, so-called melmac. Melamine formaldehyde resin. Melmac. Melamine polymer. What is the IUPAC name of melamine polymer? Option C, 2,4,6 triamino 1,3,5 triazine. And this is how the numbering has to be done. This is how the numbering has to be done. Have a look at this. Have a look at the detailed idea regarding the structural entity. It has to be numbered 1, 2, 3, 4, 5, 6. So it is 2, 4, 6 triamino 1,3,5 triazine. That is what called a melamine. Melamine. Right? And there was a previous IIT question. Old IIT question. Number of lone pair of electrons in melamine. Number of lone pair of electrons in melamine. How much? How much? As many nitrogen atom, as many lone pair. So each nitrogen contain a lone pair. 1, 2, 3, 4, 5, 6 nitrogen are there and there are 6 lone pair of electron. That was a question. And that is what I am commenting regarding the importance of structural entities. Next question. The number of average molecular mass and mass average molecular mass of a polymer are respectively 30,000, 40,000. Polydispersity index. See, polydispersity index, a very important index regarding the nature of the polymer and their polymeric chain characters. Right? Now, how to find the PDI value? PDI value is so determined. Have a look at this. PDI is equal to weight average molar mass divided by number average molar mass. 40,000 by 30,000, you are getting 1.33. And it is more than 1. What is the meaning more than 1? What do we understand more than 1? PDI index. What is more than 1? PDI index more than 1 means polymer has extra chain as compared to actual molecular chain. Whatever the actual chain we are expecting, there are extra chain. That is what happening in synthetic polymers. While natural polymers, expected and actual chain will be almost the same. And you can see PDI 1 means that polymer chain are of same molecular weight. All polymer chain of the same molecular weight, that is expected to be a natural polymer, and PDI for natural polymer expected to be 1. For synthetic polymer, it is expected to be more than 1. So PDI can be equal to 1 or more than 1. Okay, next. In a polymer sample, 30% molecules have a molecular mass 20,000, 40% having 30,000, rest 60,000. What is the weight average molecular mass of the polymer? How to find the weight average molecular mass? Weight average molecular mass is determined by this equation. What is that? Sigma NiMi square by sigma Ni. So how do you do that? Sigma NiMi square. That means percentage into percentage into molar mass square. So 30 percentage into molar mass square, 40 percentage into molar mass square, and the remaining for 30, 40 means 70. The remaining 30 percentage into molar mass square divided by the percentage into molar mass. You look at this formula, apply in that formula, and you are getting your answer. You must get your answer the way 43, 333. Option C. This is out of syllabus. Earlier it was there in the NCERT. So better to go through it as a additional point of information. Okay. While the number average molecular mass will be determined by that equation. Number average molecular mass. Okay. Next. Superglue is polymethyl methacrylate. Polymethyl methacrylate is PMMA. That is plexiglass. We are talking about superglue. Superglue is option C. Polymethyl alpha cyanoacrylate. This is PMMA. This is PMMA. That is plexiglass used for making lenses, plastic lenses. It is option C. Methyl alpha cyanoacrylate polymerizing. You will get a superglue, the so-called crazy glue. Polymethyl alpha cyanoacrylate. Answer is option C. Next one. A copolymer of vinyl chloride and vinyl acetate. Copolymer of vinyl chloride, vinyl acetate is called vinion polymer. Used as heat sealable fiber for tea bag industry and all. And that is vinion polymer. What is sarin? Sarin option B. And that is vinylidin chloride and vinyl chloride. Next one, dinyl. Dinyl is acrylonitrile and vinyl chloride. Dinyl you might have heard about. Used for making artificial wig. Dinyl is used for, see, all these are having various application. Famous application we are committing, that's all. So it is option A. Orlon pan polyacrylonitrile, pan referred in the text. Next one. Gutta perca is option C, natural polymer occurring in plants with the all trans configuration. Option C. It is option C, isoprene. It is polyisoprene only. Cis polyisoprene, we call it as natural rubber. That is latex. This is latex. The rubber milk you extract from the rubber tree by tapping process. That is latex. And this is gutta perca, trans polyisoprene. Here all are cis configuration. Here all are trans configuration. Next. The mass average molecular mass expressed is already commented. Option A, mass average molecular mass. Option A. Next. This is mass average molecular mass and this is number average molecular mass. This is number average molecular mass and this is mass average molecular mass. Next one. Cyclohexanon with the hydroxylamine. You get oxime. So this reactor you get option A, this is oxime. And that sulfuric acid you get caprolactam. There is no choice. This is the answer. You get caprolactam. Caprolactam is produced by that process. You say cyclohexanon treated with hydroxylamine, you are getting cyclohexanoxime, which upon H2 with the sulfuric acid, you are getting caprolactam. And what is this reaction called? You must know. Beckmann's rearrangement. Beckmann's rearrangement. Beckmann's rearrangement. Beckmann's rearrangement, where cyclohexanoxime converted to caprolactam. Next one. The monomers of nylon 26R. Monomers of nylon 26R. Nylon 26 means nylon 2, nylon 6. There is no nylon 26. It is nylon 2, nylon 6, glycine and aminocaproic acid. Already commented. Option B, glycine and aminocaproic acid. Option B. Next one. The polymer obtained from condensation polymerization of adipic acid with sebacic acid. Adipic acid and sebacic acid. It is not adipic acid and sebacic acid. It is hexamethylene diamine with sebacic acid. It is not adipic acid and sebacic acid. It is hexamethylene diamine with sebacic acid, and that is the probable combination that is happened to by some mistake. It is option C then. Let's have a look at. It is hexamethylene diamine and sebacic acid. This is not adipic acid. This is hexamethylene diamine with sebacic acid. Hexamethylene diamine already we have introduced. What is sebacic acid? Sebacic acid contains 8 carbon plus 2 carbon. 10 carbon atoms are there. That's how it becoming nylon 610. Nylon 610. 6 carbon atom in hexamethylene diamine and 10 carbon atom in adipic acid. So it is nylon 610. Option C is the correct answer. Next one. Ziegler-Natta catalyst. Ziegler-Natta catalyst is trialkyl aluminium titanium chloride. Trialkyl aluminium titanium chloride. That is Ziegler-Natta catalyst. And option B, it's very famous, you know, Wilkinson's catalyst. Wilkinson's catalyst, right? Yes. Option A, Cecil salt. Option B, ferrozine. And the answer here is option C. Ziegler-Natta catalyst, trialkyl aluminium titanium chloride. Next one. Melmac is a polymer of melamine and Melmac is a polymer of melamine and formaldehyde. Melmac is a polymer of melamine and formaldehyde. Melamine formaldehyde resin. That is called Melmac. Melamine formaldehyde resin. You see, melamine with the formaldehyde, you are getting the resin intermediate. Upon polymerization, you are getting Melmac. This is Melmac, right? And the answer is option B. And that is the last question from the concerned chapter, polymers. So we will meet with another chapter in another class. Okay? Till then, bye. Take care. See you.